1972, that was the first time the humankind took a picture of Earth seen from the space. And lots has been happening in this planet for quite many years ago. At the year minus 8,000, agriculture was invented, and this helped humankind to start establishing in Earth. But that time we reached about the same population as Sweden today, about 10 million people. The population started to grow slowly, and by the year 1800 we managed to reach 1 billion people. If we consider the entire existence of the planet, it took us 7 million years to reach 1 billion people. But then something really important and fundamental happened. And that was the Industrial Revolution. It really changed the world and started to build it the way we know it and we experience today. Because of the Industrial Revolution, more and more children started to survive and become parents themselves, which resulted in a population of about 2 billion in only 130 years. And it didn't stop there, as you know. The population continued to increase year after year as the wealth in the planet was growing as well. And by the year of 1999, just before the turn of the millennium, we were already 6 billion people on Earth. And I guess that all of us watching this presentation today were alive at that time. And it continued. So if we look at the population today, we are actually nearing to the 8 billion people in the world. And as we know, it's not going to stop there. The population is still increasing. And there are some estimations from the United Nations predicting that we will reach about 11 by the year of 2100. It's quite amazing to see this development over time and how the Industrial Revolution have shaped the way we live and enabled many more of us to live in this planet as well. But I want to go back from the beginning of this timeline and tell you the story from a different point of view. And this is from the point of view of the concentration of CO2 in the atmosphere. By the year 1800, when the Industrial Revolution started, we had about 290 parts per million of CO2. And we can see here that the biggest country in terms of contributions to emission was the UK, of course, because they were at the beginning of the Industrial Revolution. If we go further on time, we'll be able to see that by the year 1930, the world is already becoming more and more industrialized, and we actually see the emissions starting to emerge in North America, South America, most of Europe, and also Asia. Considering also South Africa is starting to go in the same direction. By the 60s, we were 3 billion people, and we are already a quite industrialized world. By 2011, 7 billion people, and the world is 100% industrialized, with virtually all the countries contributing in terms of CO2 emissions. Today, we have a concentration of CO2 in the atmosphere of about 414 parts per million, which is an increase of about 42% since the beginning of the Industrial Revolution. And as we know, this has led to a number of effects, and one of them being climate change. There are lots of initiatives today to try to understand, for example, through the science-based targets, how to keep within the planetary boundaries so that we don't surpass the tipping point in terms of climate change. But we should not forget as well all of the other environmental impacts that our actions are actually leading to, such as resource depletion, climate-induced pandemics, overpopulation, inequity, and all the climate refugees coming as a consequence of it. And if we try to understand what is at the root cause of the problems and the sustainability challenges that we are facing today, I say that most of them are rooted on the logic of a linear economy. This is the economy we've been living since the beginning of the Industrial Revolution, and it's based on three main strategies, we could say. We take, we make, and we dispose. And this has been proven not to be sustainable in many ways. If we were to continue keeping the good quality of life that we experience in the developed world, also in the countries under development, we need to find a better way of doing so to ensure that we are living within the planetary boundaries and that we are respecting the resources from an environmental, a social, and also an economic point of view. And the alternative to a linear economy is what we call the circular economy. And the circular economy aims to really try to understand how to decouple value creation from resource consumption, or how to decouple well-being and high quality of life for the entire population on Earth, decoupled from the consumption of finite resources. And then the question becomes, how do we do it? How can we actually make this transition from a linear to a circular economy? And there are some strategies, in fact, 4 strategies that can help us to understand how to do so. We can narrow and use less resources than we do today. We can slow and use the resources and the products that we have in economy today for longer and for as long as possible. When it's not feasible anymore, we can close the loops and try to understand how to use those products, components, or materials again. And then finally, we also need to understand how to regenerate and how to make our products in the cleanest possible way. I brought to you today 4 examples across those 4 strategies that actually shows that many companies are already taking the leadership in that direction. So let's start with narrowing the loops and using less. The example that I have here for you today is from River Simple. River Simple is a startup from the UK, which is thinking on mobility as a service. So their main idea is to not sell cars any longer, but to provide cars as a way to fulfilling the function that is to move from A to B. If you look at this car, it is quite different from the cars that we see on the streets today. And the reason for it is that the car was designed taking this business model in the mindset, and it has been designed in a way to be as light as possible, to be as energy efficient as possible, and to use the most possible sustainable materials across the entire value chain. So a very good example of how changing your business model can have a quite big influence in the way that you are designing your products. That was the example for narrowing or using less. Let's now move forward and understand how we can slow the loops or use products for longer. And the example that I have here for you today is from Drive Now, a car sharing system that is already quite well established in many cities in Europe. The idea here is that by allowing the product to be shared among different people, you would be able to enhance the utilization from about 5%. That's what we see in a traditional ownership model for cars, towards 30 or even 40% of utilization of those products. By doing that, we of course avoid having to manufacture more cars to fulfill the same function, and this can really help in an overall big picture to minimize the overall material consumption for those products. That was slowing and using the products for longer. Let's see now how can we close the loop and start using products again through reuse, upgrade, remanufacture, or even recycling. And the example that I have for you today here is about secondhand clothes. We know that the fashion industry is responsible for a quite big portion of the environmental impacts that we are emitting today. And the reuse of clothes can have a quite strong focus on minimizing this overall impact. So instead of having to buy new clothes every new season, and actually there are some brands having 7 or 8 seasons a year, imagine that, we are moving towards understanding how we can reuse clothes and share after use so that other people can have access to them. And here in Europe, we are quite strong in terms of secondhand shops, but also the flea markets that really help this economy to move in the right direction. For every year, we manage to expand the lifetime of any cloth item. We are actually minimizing the overall impact from 30 to 50%. So that's a quite big achievement. Moving now to regenerating and trying to use more renewable and biodegradable materials. The example that I have for you here is from Carlsberg. We were actually working together with the company to try to understand how to design a completely new beer bottle made out of paper. The idea here was that as a plan B, if the bottle ended up in nature, that would be able to biodegrade without causing any harm for the soil or the water bodies close to the disposal. And it required a significant change not only of the bottle design, but also of the entire manufacturing process behind it. So it's a quite good example how we can merge the technical cycle of a circular economy with the biological cycle of biomaterials. In this case, paper-based bottle. This gives us the 4 strategies: narrowing, slowing, closing, or regenerating. And the question is, are they real enough? I just told you part of the story. Yes, those 4 solutions, they can definitely contribute to the transition to a circular economy, but are they enough? Let's have a look into them again, one by one. Yes, designing cars to be as energy efficient as possible is extremely important to minimize the overall energy consumption. But more efficient cars are also leading to more driving. We see it over and over again that the disposable income saved from the economies in more efficient cars lead people to actually drive more, so that the overall impact is higher than expected. If we talk about car sharing initiatives, Yes, car sharing really helps with a higher car utilization, and this is extremely important. But we also see significantly shorter lifetimes of those cars in comparison to the enhancement of utilization. So in the end, we are actually having a higher impact than before, simply because the cars, in most of the cases, are not designed to be put in those shared systems. And there are changes in consumer behavior that drive this higher wear and tear, leading to a shorter lifetime. So yes, car sharing systems enable a higher utilization, but they also lead to shorter lifetimes. Let's have a look now into the second-hand clothing and using again. Yes, second-hand clothes are extremely important. It will help us to minimize the amount of new clothes that we are buying. But the problem is that in most cases, they're actually not replacing new clothes, but they're actually bought in addition to new clothes. And this is a problem. So we are not substituting new goods by second-hand goods. We are just piling them up. Yes, second-hand clothes are important, but today they are bought in addition to new clothes. And finally, looking into the regenerate, biodegradable is important, but the problem is that when users know that those products are biodegradable, what they tend to do is simply to litter. It is sustainable already. Why do I need to care about it? And this is, of course, not the best option in terms of recycling. So the way we communicate about the sustainability performance of our products is extremely important. We do not want to take out the responsibility from the users when deciding what's the best end of use or end of life strategy for those products. All in all, yes, we see lots of potentials in implementing circular economy strategies, and we definitely need to do it more and more and more. But we also need to be aware of what are the potential unintended consequences emerging from the implementation of those circular economy strategies. And the biggest question then becomes, how can we avoid the unintended consequences of circularity in order to be able to enhance the overall sustainability performance and live within the planetary boundaries? And I've been thinking a lot about that, and I have two main proposals on how we can further advance science to be able to do so. The first one is to expand the level of analysis that we have today for designing new circular solutions, from materials and components to products and product service systems. And I would say even going one step further to understanding how to design social technical systems that are resilient to those unintended consequences of circularity. That is my proposal number one, to expand the scope of analysis and the scope of design from materials, components, and products towards product service systems and social technical systems. We need to have a systemic view for the implementation of circular economy and the identification of potential unintended consequences when doing so that we can avoid them to happen. And then my second proposal and my second approach to avoid those unintended consequences would be to, in addition to having an inside-out view, in terms of having a problem and trying to find what's the solution for this problem, would actually complement that with an outside-in view, where yes, we come from the problem, we find a possible solution, but then we go 2 steps further. The first one, in order to be able to understand what could be the potential unintended consequences of those solutions. And then afterwards, on the basis of this understanding, to design and redesign the solutions up until we reach a robust stage that will ensure system change without the unintended consequences. If we manage to combine this systemic view with this understanding of what is the impact of our solutions and how we can avoid this impact to be negative, I believe that we will be able to avoid the unintended consequences of circularity. And I would argue that this is one of the biggest challenges that we face today in sustainability research and in circular economy research. And I truly believe that at the moment that we manage to avoid the unintended consequences of circularity, then we are going to be able to develop solutions that are systemic, that can have a positive sustainability outcome from a social, environmental, and economic perspective. And at the time that we manage to do it, hopefully we will be able to live again within the planetary boundaries when we reach 11 billion people on Earth. Thank you very much for your attention.